Hello and welcome back for lesson 5.3. We're going to introduce a new distribution. And so we've looked at a little bit about the mean and standard deviation, measures of central tendency with quantitative data. And then in chapter 4, we moved into probability and qualitative data. And now chapter 5 is looking at a new distribution with qualitative data, and that's called the binomial experiment. So there are 4 characteristics of a binomial experiment, and you will need to prove these. So there are a fixed number of trials. Think of trials as repetitions of an experiment. The letter N denotes the number of trials. So a fixed number of trials is the key. There are only 2 possible outcomes. We're going to call that a success or a failure. For each trial, the letter P denotes the probability of success on one trial, and Q denotes the probability of a failure on one trial. So we have success or failure. Then the third is we define X as the number of successes. So X can be anywhere from 0 successes all the way through N successes. So if you go back to the basketball player shooting the free throws, he could have 0 successes, or he could have 3 successes where he made all 3 free throws. The fourth characteristic is that the N trials are independent and are repeated using identical conditions. Because the N trials are independent, the outcome of one trial does not help in predicting the outcome of another trial. Another way of saying this is that for each individual trial, the probability P of a success and probability Q of a failure remain the same. For example, randomly guessing at a true-false statistics question has only 2 outcomes. If a success is guessing correctly, then a failure is guessing incorrectly. Suppose Joe always guesses correctly on any statistics true-false question with probability of 0.6, then Q must be 0.4. They must add to 1. The outcomes of a binomial experiment fit a binomial probability distribution. The random variable X is equal to the number of successes obtained in the N independent trials. And then to calculate the mean for the binomial probability distribution is by taking N times P, and the standard deviation, sigma, is calculated as sigma is the square root of N times P times Q. And remember, Q is 1 minus P. This is called a Bernoulli trial. Any experiment that has characteristics 2 and 3 where N equals 1 is called a Bernoulli trial. So it's either a success or a failure. Let's look at some examples here to help us make some understanding of the concepts. Example 1 says at ABC College, the withdrawal rate for an elementary physics course is 30% for any given term. What would we define as a success? So any student who withdrew, that's who we're counting. We're counting how many withdrew because we're looking at the withdrawal rate. What would we define a failure? Any student who did not withdraw. What is the probability of failure? Well, we said P is the probability of success, and that was 0.3. So Q must be the probability of failure, and that's 1 minus P, or 1 minus 0.30, or 0.7. So 30% of the time, students withdraw from this elementary physics course, and 70% of the time, they do not withdraw. P and Q are complements. Example 2. The State Health Board is concerned about the amount of fruit available in school lunches. 48% of schools in the state offer fruit in their lunches every day. This implies that 52% do not. What would we define as success as? Success would be any school that offers fruit in their lunches. What would we define as a failure? Any school that does not offer fruit in their lunches. What is the probability of failure? So P is the probability of success. And we said that that was 0.48. And then they said that, that this implies that 50% do not. And that's because Q is equal to 1 minus P. So 1 minus 0.48 is 0.52. Another one. Suppose you play a game that you can bite, that you could either win or lose. The probability that you win again a game is 55%, and the probability that you lose is 45%. Each game you play is independent. What will we define as a success? A game that you win if you play the game 20 times, write the function that describes the probability that you win 15 of the 20 times. So this is the probability of x equals 15. We're going to learn how to find that out. Okay, example 4. The trainer is teaching the dolphin to do tricks. The probability that the dolphin successfully performs a trick is 35%. Out of 20 attempts, if you want to find the probability that the dolphin succeeds 12 times, state the probability question mathematically. That would be the probability that x equals 12. Okay. Example 5. A fair coin is flipped. Each flip is independent. What is the probability of getting more than 10 heads? Let x equal the number of heads in 15 flips of the fair coin. X takes on the values of 0 through 15. Since the coin is fair, the probability of success is 0.5, and the probability of failure is also 0.5. The number of trials is n equals 15. State the probability question mathematically. And we want to get more than 10. So that's the probability of x being greater than 10. Strictly greater than, because it said more than. We cannot include 10. Next, we have a paired 6-sided die is rolled 10 times. Each roll is independent. You want to find the probability of rolling a 1 more than 3 times. State the probability question mathematically. So let's just write out x is the number of ones rolled. So we want the probability that x is greater than 3. Because we want to know what is the probability of rolling a 1 more than 3 times. Example 7. Approximately 70% of statistics students do their homework in time for it to be collected and graded. Each student does homework independently. In a statistics class of 50 students, what is the probability that at least 40 will do their homework on time? Students are selected randomly. This is a binomial problem because there's only one success or failure. There are a fixed number of trials and the probability of a success is 0.7. if we are interested in the number of students who do their homework on time, then how do we find X? X is equal to the number of statistics students who do their homework on time. What values does X take on? X can be anywhere from 0 students, 1, 2, all the way up to 50, because there were 50 students in the sample. What is a failure in words? Any words is any student who did not do their homework on time. If P plus Q equals 1, then what is Q? So they told us the probability for success is 0.70. That means that the probability for failure, Q, is 1 minus 0.70 or 0.30. F says the words at least translate as what kind of inequality for the probability equation? The probability of X at least is a greater than or equal to, because we have at least. Example 8 says, decide if the following situations could be considered binomial experiments if they are then defined X, N, P, and Q. So A says 65% of people pass the state driver's exam on the first try. A group of 50 individuals who have taken the driver's exam is randomly selected. Give 2 reasons why this is a binomial problem. So we know this is a binomial problem because we have a fixed number of trials. We know that you can either pass or fail. So 2 outcomes that are independent. Each driver is independent from another. And the probability for success, P, equals 0.65. And that means the probability for Q is 1 minus 0.65 or 0.35. B says, a lacrosse team is selecting a captain. The names of all the seniors are put into a hat, and the first 3 that are drawn will be the captains. The names are not replaced once they're drawn, because one person cannot be 2 captains. You want to see if the captains all play the same position. State whether this is binomial or not, and state why. Okay, so do we have a fixed N? Well, we're drawing 3. N is 3, we're drawing 3. Now, the probability is not going to be the same, because we can't, when we draw from the hat, it changes. There's 1 fewer person now left in the hat. And so because it is not with replacement, it's a dependent situation. And so the probabilities are changing. So this would not be considered a binomial experiment. Catch me back for the second part of this 5.3 lesson.